All right, we are doing linear graphs today and using them. So for our viewers at home, I already gave them a lot of time to write down the problem, so we're going to breeze through really fast. So if you need to write them down, you might want to pause it. Okay, does anybody have an idea of what depreciation is, or if something depreciates, what that means? Jared?
It's how something loses value over time.
Okay, it loses value over time. Okay, so loses value over time. Can anybody think of any real-life examples of things that lose value over time?
The equity on a house.
Okay, yeah, that's good. House equity, that's a big one. Anything else? Yeah.
Well, cars lose like a third of their value as soon as you leave the lot.
Brand new cars lose, yes, quite a bit of value as soon as you drive it off the lot. Anything else that you guys can think of? What's that?
Moral values.
Moral values. Sometimes. Do we need to have a Dr. Phil speech in here?
Yes.
Yes.
It would be Dr. Phyllis.
Dr. Phyllis. That's true. All right. I will save that. That will be the light at the end of our word problem tunnel for the day, is our Dr. Phyllis speech. Okay. How about, so if depreciation is decreasing in value over time, what do we think appreciation is? The opposite way. So you're appreciating. So can anybody think of anything any items or anything really, morals maybe, that can appreciate? Yeah, Lydia?
Well, my mom sold off her gold jewelry, and it turns out it was way more than she thought it would be.
Right. Good, that's a good one. So jewelry a lot of times will appreciate over time. Anything else? There are a lot of stores out there that have certain items. Yeah. Quebec, okay, good, like antiques, right. There are a ton of antique stores out there that have a lot of things with a lot of really big value. Rachel?
Oh, well, my grandpa always gets us coins, and he always says they're worth a lot of value. So, like,
yep, coins can be, that's very true. I used to collect, my mom decided when I was really young that I needed to collect something. I didn't feel the need to, but she insisted I needed to collect something, so I had to pick what I wanted to collect. And stamps.
Was it stamps?
Well, it was stamps. Yeah, stamps. And then she made my sister collect something. She collected coins. I never did anything with them. I just, okay, Mom, I'll collect. Good, now, get off my back. Okay. All right, here we go. So we are looking at depreciation and appreciation today. So, Carl Robbins purchased a small apartment house for $90,000. For tax purposes, Carl assumes that there was a depreciation of 6 2/3%, 2 over 3, per year on the property. All right, the first thing that we want to do is write an equation for the value V of the property after T years. Okay, so how many people would agree, clap if you agree, that the present value of the house is $90,000? We are assuming at this point in time that this is the value of the house.
Oh, yeah.
Okay, that's good. Okay, so the present value. That was kind of scary. But we all agreed at home that I'm sick today, and so my verbiage is not the best. Present value is $90,000. Now, so what we're doing is we want to write an equation for the value of this house as it decreases per year, okay? So, if we know that it decreases at a rate of 6 2/3% per year, is there some way that we can figure out how much money that is decreasing per year? Yeah, Marcy?
You multiply the percentage by the current value.
Good.
And then you minus it.
Perfect. Okay, so we do 0.06 2/3. That's the same thing as 67. We can go on and on and on. Times, so we're converting the percent to a decimal, times $90,000. And again, we're doing this because we want to figure out how many dollars it decreases per year. Not percent, but dollars. So we want to convert that. So if we multiply that out, it's approximately, let's put the approximate symbol, $6,000 that it depreciates per year. So we want to, whoops. Okay, so we want to get an equation that represents how much this property starts out at, and then subtract off how much it decreases per year. So what do you guys think? Marcy?
I would multiply the present, or the depreciation
by the number of years.
Good, perfect.
And then subtract that from the current value.
Exactly. So let me just rephrase what Marcy just said. How many people clap if you agree that the value is, that's good. He agrees with the value is. Nicely done. The present value, if you take the present value and subtract off how much it's depreciating every year, depreciation per year, let's see, how do I, that will tell you the value at any certain number of years. Does that make sense to everybody? Clap if that makes sense. Okay, so the present value is $90,000, and it's depreciating, like Marcy said, at $6,000 per year times t years. Okay, so if we want to find out how much it's depreciated after 3 years, could we do that with this equation? Yes. Okay. Now, we're going to be asked to graph it. We're going to do that next. We're going to ask to graph it and then use the graph to figure out how long it takes to depreciate to other levels, but you can also use the equation to do that. All right, somebody draw a graph on your paper. So we're going to do, let's see, that was part A. This is part B. T goes on the x-axis and V goes on the y-axis. All right. So we know that we're going to have to get up to at least $90,000. Anybody have good units? Oops, sorry. Anybody have units, what our increments should be on the y-axis if we have to get it all the way up to $90,000? 10,000, good. Hit 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm going to put 90K, 80K. This is where these pens are not the best in the world. 40, 50, 60K, yes. Okay. I'm going to go on the t-axis, I'm just going to go by twos, okay? So 2 years, and this is in terms of years. This is in terms of dollars. Sorry, I know this is where having a nice huge whiteboard to write on is helpful. 2, 4, 6, 8, 10, 12. Okay. Can you guys see that okay? Put that there. So I went by twos on the x-axis and by 10,000s on the y-axis. Okay, so if we want to graph this, what do you guys think? How can we graph? Where's the y-intercept or the v-intercept? 90,000. Let me use a different color pen on here. 90,000. Oops, I lost all my pens. Here we go. All right, so 90,000, that's where it starts now. Is there a way that we can figure out where it's going to intercept the t-axis? Or what? You guys tell me. What can I do next to get the next point to graph it? The slope is negative 6,000 or negative 6,000 over 1. Could I use that if I wanted to graph it? Okay, how would I do that? What would I do? Go down 6,000 and write 1. Okay, good. We could also, yeah, okay, so if we go down about 6,000 and write 1, remember since we went by twos here, that's going to affect where that point goes. Okay. Just check something here. What's that?
Was that after 2 years?
That was after 1 year. So to get the point from the second point, you can go down about 6,000. This is obviously not the most accurate graph on the planet. Go down about 6,000 and write 1. You can also, does anyone have another way of doing it that's more, maybe might be a little more accurate? How would I get the x-intercept?
Hold on.
Yeah, Marcy?
Where's the end of your graph? I mean, oh my gosh.
Where's the end? Which end?
The bottom end.
Right here?
Yeah, I can't see it.
This number? Okay, so 2, 4, 6. So right here, this is 14, 16, 18, 20. So it should fall somewhere in between 14 and 16. Okay, so let's suppose... What's that?
How did we get that number after the number of
It's
years?
an approximation. I would say the easier way of doing it, though, is if we can get the x-intercept or t-intercept by plugging in 0 for v and then solving. So you can do 0 equals, excuse me, 90,000 minus 6,000 t, and then get t by itself. That's another way of doing it. That's more accurate to do it that way. All right, so use the graph to determine how long it'll take for the value to decrease to $30,000. So $30,000 is right here. So if we're using the graph, there's another way of doing it other than the graph, but that's going to be about how many years? If this is $30,000, 9, 10, somewhere in there. So it's an approximation, so we're kind of off the hook here. So that C is approximately 9 to 10 years. Okay, so that's if you're using the graph. But who can tell me the other way of doing it that's actually more mathematically accurate of figuring out C? Lydia? Good. So you can put in a V of $30,000 and then isolate T. Yeah, and if you do that, you'll get T is 10, exactly 10 years. Okay, questions on that? Yeah.
Are we going to be able to use our calculators?
Yes. Okay, so for problems like this on the test, you're going to get, if you get a problem like this, you'll get really easy numbers to figure out. Yeah.
And are we going to be finding the exact numbers on homework?
I actually don't remember. I'll go back and look. Okay, other questions? Okay, let's move on to the next two. All right, so the next two, all we're doing is setting up the equation like we have here. All right, so I'm going to pause it for a second. I'm going to give you guys a couple minutes to work on these two. Okay, let me move this up. And I'm going to ask for volunteers to come up and show. All you're doing is writing the equation for these two. Okay, so that was part A in the last one. All right, I'm going to pause it. We will be right back. Give Riley a round of applause. She's going to come up and show us how to do the first one. Whoops, let's get this set up. Would you like pink music?
Sure.
Okay.
Oh my god, I will.
We have math, pink music.
Yeah. Here we go. Yeah. Here we go. I'm talking about math.
All right, everybody clap if you agree with Riley. Yay. Okay, before we get to the next person, we are having a debate over here. So, for people who did not hear the debate, for those people who do not want to be on camera, we have an idea that for those people who don't want to be on camera, we have stand-in dancers because Mr. Underhill and Mr. Salmon are doing the dances over here. I am not going to put him on the spot because he did not put himself on the spot. What do you guys think of that? Would you like to see them dance? Clap if you would like to see them dance. I think you guys have an audience. Okay, so just for people at home, I equals 5,000 minus 300t. Okay. Next person, Marcy, do you want to be on camera? Yeah. Yes? Okay.
Oh, okay, no. Hi.
Oh, no. Okay. All right. Do we have our dancers?
I thought you wanted to be on camera.
No, it's okay.
Totally.
You can be on camera.
It's okay.
Okay.
I don't have a camera face.
Yes, you did.
Guys ready? You gonna come up? Everybody give Marcy a round of applause.
Yeah.
You guys gonna chicken out now?
Get on camera.
I don't want to be on camera.
Have math, they could charge us hidden fees on my cell
Come
phone.
on. Now you're comfortable.
How we gonna dance?
Oh my God.
Like 1, 2, 3, 4. We can hear it on the TV, read it on the floor. Some say a waste of time. When they doing it for us, it ain't gonna end up again. Sweeping up the floor. Shout out to Miss Miller and even Mr. D, Miss Barnett, and Mr. Humphreys from algebra to trigonometry. If it wasn't for math, where would we be? Shout out to Miss Miller, and even Mr. D, Miss Barnett, and Mr. Humphreys.
I am embarrassed for you. You are great. Keep it going. You guys, they need some, they need some encouragement. Give it up for our dancers. Oh, you're gonna get shy now.
After the round of applause, we get back.
No, they're cheering you on. They want to see more. Christian's still going.
Nathan, since when do you get shy?
Okay.
No, honestly.
Clap if you agree with Marcy. Marcy's got 500 plus 75T. Okay, yeah. All right. How we doing on questions?
Oh, wow, I read it.
Yeah. It's a plus. Yeah, 500 plus 75T. Now, okay, somebody else for another extra credit point. Can somebody tell me, I have hands up already and I have not asked the question yet. This is how awesome Accelerated Algebra 2 is at this school. Okay, so can somebody tell me why this is plus instead of minus for an extra credit point? Why is this a plus instead of a minus? Okay, let's see. Jonah. It's appreciating. Everybody give Jonah a round of applause. Thank you, Jonah. All right. Now, let me ask a question. I do have one more example, but do you guys, what do you think? Do we want to go through it? No? You guys are all good? It makes sense? Everything's great? The graphing? The next one has a graph. You guys want to do it? Okay, fine. The enthusiasm in here is just too much to bear. We say, yeah. Okay, so the graphing. Let me show you guys a really easy way to graph. Let's really quickly go through this last problem. All right, so can somebody set this up for me? We have, okay, Ashley, yeah, and let's do extra credit on these too. Let me keep track. Okay, so go ahead.
Do you want me to go through the whole present value equals?
Yes.
Okay, the present value is $40,000.
Okay. Hold on a minute.
So the appreciating value is 40,000 times 0.125.
Good. So where did you get the point 125?
From the half of 12, so that would be
Good.
1,000.
Good. Okay, so that when you multiply that out comes out to what?
Oh, that'd be useful. 5,000.
I'll tell you. It comes out to 5,000. Okay, so then if I set up my, so can somebody tell me, we now have a present value, thank you, Ashley. If it appreciates $5,000 per year, what does the equation look like in this case? Let's see, Lydia? Good, 40,000 plus 5,000 T. That's the equation that we're going with. Are there questions on the equations and setting them up? Okay, now the graph part. The graph part is, I'm trying to do some serious multitasking here. Okay, so we have the value V on the y-axis and T, or number of years, on the x-axis. So remember this one, if we look back at y equals mx plus b, it's the same exact thing. Instead of y and x, we have v and t, but same concept. Okay, so the number that doesn't have a variable attached to it, that's our y-intercept. And then the number that does have a variable attached to it is the slope. So in this case, let's see, let's just go up by 20,000. Ooh, yeah, let's 40, 50. Nope, let's do tens again. 10, 20, 30, 40, 50, 60, 70. Okay. And there's a K there for 1,000. Shh. Okay, so if you are good to go on this concept, and you don't need to pay attention, so there are people in the back that are not paying attention. That's fine, but don't. Okay. Along the bottom, I'm going to go by ones this time. Hopefully it'll make it a little less confusing. We'll find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you guys see still? I know the pen is kind of hard to see. Here, let's zoom in. Okay, now our y-intercept is 40,000, so that's the first point, is right here. Clap if you understand why the first point is at 40,000. So I can see where we're getting confused. Okay, next, if our slope is 5,000, positive 5,000 or 5,000 over 1, what does that mean for us in terms of getting from the first point that we put on here to the next one? Akashni? Good? Good. Up 5,000. So if you see here, 40 and 50,000, that's a 10,000 difference. So you go up 5,000 or halfway to the right one. So these are whole units. Does that make sense to everybody? Up 5,000, right one. Up 5,000. You can keep going over and over like this. Okay, so then we connect those with a straight line, this is where a ruler actually does make a difference and helps give you a more accurate graph. Are there questions now? Okay, use the graph to determine how long it'll take the value to appreciate to $65,000. So from here, I go up to 65,000, which is right here, and I draw a line over to the value curve that we just drew, value line that we just drew, and then straight down. So how many years is that?
4.5.
4.5. Good. So C should be approximately 4.5 years. And then D, use the graph to estimate the value after 8 years. So how are we going to do C? Sorry, D.
Go from 8 up.
Good. We're just going backwards. So we start at 8, which is right here, and we draw a line straight up to the value line that we just drew, and then over to the v-axis. So what is the value, approximate value after 8 years? 80. Now you can also go through, so it's approximately $80,000. Remember we said for all of these you can go through and plug the numbers into the equation and figure it out that way. Okay, are there questions? Does that clear it up a little bit? Okay. All right, so, whoops, let me put the assignment up here so you guys know what you're working on. So this is homework number 13, page 85, word problems, numbers 1 to 9 all. They're all this level of difficulty, so if you guys understood, you're good to go. All right? Put that there.